Hello and welcome. In this video we are looking at relative formula mass and how to calculate the relative formula mass for different substances. Now, first thing to remember is relative formula mass can be abbreviated as M with a small r, and to work it out it's a very simple case of adding up what we call the relative atomic masses, or all the relative atomic masses for the different elements that are present in the compound, or the different atoms that are in the compound. And a way to abbreviate relative atomic mass is A with a small r, and basically the relative atomic mass is a number that's very close to, or if not the same as, the atomic mass. Occasionally it's different if you've got these things called isotopes, but what they do is they give you this in the question itself, so you don't have to go and look it up anywhere on the periodic table or anything like that, so that makes it a little bit easier. Now, as we said, to calculate the relative formula mass, we add up the relative atomic masses. So here's a compound, it's water. How would I find the relative formula mass? Well, we need an extra bit of information, and that is the relative atomic masses. And for hydrogen it's 1, and for oxygen it's 16. So here's the molecule of water. We've got H2O. The 2 is to do with the hydrogen, so we've got 2 hydrogens. So here's our hydrogens, and each one has a relative atomic mass of 1, and the oxygen has a relative atomic mass of 16. So it's just a simple case of adding them up. So we have 1 plus 1 plus 16 equals 18. There are no units, so we say the relative formula mass for water is 18. Here's another example. Here we've got methane, which is CH4. Remember, the 4 is linked to the hydrogen, so we have 4 hydrogens, and here's what an atom of that might look like. So we've got 1, 1, 1, 1. What is it for carbon? In actual fact, they do give it to you in the question, so I'm going to do the same. I've just abbreviated it here as AR. Remember, that's a relative atomic mass. For carbon it's 12, and for hydrogen it's 1, so we've got 12 for the carbon and 1 for each of the hydrogens. So it's just a question of saying 12 plus 1 plus 1 plus 1 plus 1, and a simpler way to do that, I guess, would be just to say 12 plus 4 times 1, and then that there would be 16. So the relative formula mass for methane is 16. Again, remember, no unit. Now the best thing to do would be to go ahead and try some of these for yourself, so you can pause here. Let me just give you the data that you need, the relative atomic masses. You can pause here, try these out for yourself, and then start running the video again, and you can check the answers to see if you've got it right or wrong. There is a little mean one here that is quite complicated to do, but I've just thrown that in just for practice. They don't often give you one like this in the exam. If they did, I think it would be pretty mean of them to do that, but let's not take any chances and see if we can work these out. Right, so for magnesium chloride we've got MgCl2. Remember, the 2 is refers to the number of chlorines, so we've got Mg, a chlorine and a chlorine. And if you look at the relative atomic masses for magnesium, it's 24, and for chlorine it's 35.5, add 35.5, and that would be 94. Remember, no units. For oxygen it's just 16 plus 16, or 16 times 2 is 32. For sulfuric acid, H2SO4, that would be 1 plus 1 plus S is 32. 4 oxygen, so we can just in brackets say 4 times 16, and the answer to that would be, that's 32, 64, 96, 97, 98. And for aluminium sulfate, this is the complicated one. I'll put the calculation on the screen there for you, and you can see whether you got that right or not. So there's the one for aluminium sulfate. You've got aluminium, which is 27, has a relative atomic mass of 27, so there's 2 of those. But remember, the SO4 here, the 4 applies to the oxygen, so there I've put the 64 there because that's 4 16s. But we've got brackets